at 5G and OIT. Ahmed Abdelhamid, angel investor at Right Electric Egypt. Islam Kandil, head of Telco Technologies, Intel Middle East, to talk to us about the pivotal role of semiconductors in emerging technologies.
لا اتفضل.
We will take it. No. We are having one more. We're having an next one. There are two of them on our camera. Assalamu alaikum, bismillah ar-Rahman ar-Rahim. Thank you guys for attending this panel. I know it's really long day and you guys have been all around GITEX. Hope you are enjoying it. My name is Khalid Mukhtar and I will be moderating this very intellectual panel with my honorable guests. First of all, two of our honorable guests have apologized, but they can't come to Dubai. They couldn't make it to Dubai for other engagements. So sorry for them and they are apologizing, and I'm apologizing on their behalf, Dr. Hisham and Dr. Bakr. So we'll start our panel with our honorable guests here, and I will take it from my right-hand side, Dr. Ahmed Abdelhamid. Please, if you can shed a light on your experience, who you are to the audience, and we can take it from there.
Hello, my name is Ahmed Abdelhamid. I'm a PhD in nanoelectronics, couple of master's degrees in business governance. My major focus in the last 7 or 8 years have been venture capital, private equity, structuring funds. So you can say that I have background at both science as a scientist and also finance and funds. Currently, I hold some roles. I'm the managing director at AUC for DeepTech. That's a program for Africa, African DeepTech. I'm also an angel at multiple startups and funds, and I manage funds.
Thank you, Dr. Ahmed. And again, our panel is a very intellectual one. This one, we're specialized in a very deep technology, which is semiconductors. We'll go to this journey with our honorable guests. And again, I would like to open this discussion with you. So whenever we have any questions on the go, I will be happy to take these questions. Moving on with Mr. Islam.
Thanks, Khaled, and thanks IEEE for this panel and being with you today. I'm very happy to be with you. My name is Islam Kandil. I'm Intel lead for Teleco vertical in the Middle East. Our main objective here is to be like the catalyst of the technology transformation within the sector of communication service providers and cloud providers within this region. Very happy to talk about one of my beloved topics, semiconductor, which is, yes, Intel is in a competition from a year to year to be number one or number two of the
global leader
by production. But this is one of the areas that I believe that all what we see in the current modern society, all the technologies are based on semiconductor. And to be frank, without semiconductors, so many things we are having today was not going to be available. So very happy to be one of the guests in this interesting panel, let's say.
Happy having you, Islam.
Thank you.
Moving on with Sir Ahmed, please. Ahmed Darwish, introduce yourself to the audience.
Thank you all for having me here today. I'm really like to express my gratitude for the IEEE team for inviting us. My name is Ahmed Darwish. I've been working deeply immersed in the telecom sector for the last 15 years. Working on different cellular technologies, 4G, 5G, IoT, exploring the areas of O-RAN, and witnessing the digital transformation within the teleco sector, where we apply the different emerging technologies. Thank you.
Thanks, Ahmed, and welcome everyone to this panel. And as the title of the panel, the pivotal role of semiconductors in the deep technology and how we are shaping the future with this kind of technology. And definitely, we are not here to express how important semiconductors are to the technology, because this goes without saying. But what we want to understand, and I will begin with Islam, what we want to understand, what is the global perspective of the industry itself? How the industry portfolio is, or how the industry, let's say, steps from starting with the sand till we have a semiconductor or an IC or whatever we call it in the industry. What are the different journeys that we take till we have a chip in our hands?
So first of all, semiconductor industry today is around $600 billion of size, of revenue size. We are expecting that by end of this decade, we reach to the $1.4 trillion. So this is one of the most biggest industry worldwide. And as we mentioned before, this is a vital in each and every other industry. So it's become like the component of the future or the component of any other technology we see today in our hands. You mentioned sand. Yes, semiconductors start from the silicon, which coming from the sand. So it's everything belong to the sand, belong to the earth, like us. So semiconductors start from the sand, then it's purified, then it's silicon become what's called ingot, then sliced, then manufactured into one of the most sophisticated technology worldwide. Few days ago, we saw the iPhone 15, which is the technology, 3 nanometer technology is used inside. We are still expecting that more sophisticated technologies to be brought to these technologies. And we are expecting to see even the angstrom size of the technology. But it's not only manufacturing, there is also the design. And some reports are talking about that in the modern technologies for semiconductor manufacturing, we see like 60% of the process is about software, because we need to deal with a lot of modeling, a lot of process modeling, designing, a lot of things. So although the semiconductor is a pure hardware technology, today it's very highly dependent on software from manufacturing perspective, but also from usage perspective. Today we have a lot of technologies that is based on programming of existing chip, building software that run on a CPU or a processor, which is also another kind of semiconductor manufacturing or a semiconductor process. So I don't think that there is an accurate report to tackle all of the aspects of how these semiconductor technology limits. I think it's now the software and hardware, there is no fixed line between them, and there is a lot of things coming together to build the technology of the future.
Great, thank you a lot, Islam. And I want to take this conversation into how the global, I don't want to go into a geopolitical perspective, Dr. Ahmed, but how the global business market looks like. And from your perspective, I know that you have your patents in the IC, so definitely you know more than any one of us how this global market is shaped. Where is the power of this market, and maybe what is the opportunities in the region for this kind of market or kind of business model?
So typically when it comes to mind, and I think it's a misconception that most of people, when they think of semiconductors or semiconductors engineers or nanoelectronics designers or engineers, they think of something tangible, meaning these guys are working in factories, maybe under the microscope, delivering or developing something. Well, the fact is most of the guys at Intel, and Intel is a very special case because they are a fab company. We work typically on PCs, so typically most of the design is done on software, so it's a software sort of industry. It's not really software, it's parallel software, it's a hardware software, it's a different, and for sure there is the manufacturing part, which is fabs. Most of the companies at some moment in history have become fab light or fabless, meaning they do not have any fabs anymore, unlike Intel and very few companies who have taken the decision to maintain their factories. With the current situation globally and between the US and China, the China-US tension, our region might have an opportunity for many reasons. To start with, the Americans have taken a decision to ban some specific technologies from China, all of a sudden this region have become the go-to for Chinese companies who are looking for emerging technologies or emerging developers. That's one side of the equation where we can work. Services in general, design services are flourishing in our region. So on one hand, you have the decision makers who are focusing on building fabs or factories, including in the United States. Whereas most of the fabs and most of that work is done in Taiwan, TSMC. This region holds a capacity, as my previous colleagues have mentioned. In Egypt alone, there is over 6,000 semiconductors designer engineers. They are all working from Egypt. These are the people where Intel itself, I think a few years back, Intel acquired a company in Egypt with over 350 engineers, and they took 60 engineers, 60, and they moved them from Egypt to Germany, Munich, with all their families, and they were very well paid. That's one thing. So our region is full of talent. We have an opportunity maybe at the design and services, maybe not at the manufacturing. We are bad. We are not there yet. I don't think we will be. However, even in manufacturing, the technologies where there is restrictions from the United States and Europe, where most of the elite make their money, as Ursula said, is the new technologies, 2 nanometers, 10 nanometers, which is only 5 to 10% of the whole market. The other 95 to 90% is automotive and other consumer electronics, which goes into your typical washing machine, fans, and so on. And all of these markets are untapped. That's the tail. And this is a very huge opportunity for this market. So in fact, the tension that is happening wherever is an opportunity for this region. On one hand, NVIDIA is becoming all of a sudden a competition to Intel. They have made a huge sale of GPUs to Emirates, where we are, and they are used to produce large language models for generative AI. So where that tension have prohibited China from having access to that technology, in UAE, there is access to this technology, and in Saudi Arabia. And I can extrapolate further.
Yeah, definitely. I'll get back to you with maybe some examples or use cases or things on your mind regarding the design phases and how the business models and business perspectives are. But let me move to Mr. Ahmed and move the conversation somehow into the applications phase. How the semiconductors, this very long industry, this very long process, now it is between our hands. Now it is helping the telco and IoT industries to boom, the AI industry to boom. How it contributed from your perspective, and how these kinds of applications are booming in the next phase because of the semiconductor industry and the semiconductor development.
One way to look at is how the semiconductor impacted the industry of the telecom applications. And the most obvious case is the mobile or the handsets, or how whenever the 3GPP releases a specification or standards for the next coming futures, new technologies, the vendors start adapting such technologies to the baseband units and the radio units. And here I'm talking about the vendors from the baseband point of view of the network architecture. And then the handsets start to follow. And usually it could take some years in order for the handset to start adapt such new technologies. For example, when you're talking about functionalities like the carrier aggregation or the higher modulation techniques. So, for example, the Snapdragon 8 Gen 3, which is about to be published by end of this year. So it's all related, even when it comes to topics related to the network architecture, for example, applying SDNs and NFVs. And whenever there's a node in the telecom network architecture, there'd always be semiconductors involved. One use case I found it interesting is also the O-RAN, where there's one company, I believe it's the first semiconductor vendor, where specifically working on SoCs specifically made for the O-RAN, because semiconductor companies like
you mean the Open RAN?
The Open RAN.
The Open RAN.
Open RAN is mainly to disaggregate the baseband units and the radio units, promising a better efficiency from the network side, increasing the openness where more innovation can take place in terms of 5G and 4G standards. Also, one way to look at the semiconductor companies in general is they are not going to play a role just being a component provider. They have to look at end-to-end and look at the higher stake for a solution like we just mentioned this company for Picocom, which is dedicating a special chip for the certain use case, which is the ORAN.
And that's impressive, to be honest. And we'll get back to this again. But there is a question that came to my mind, to be honest. And it just came to my mind. If I don't want to put anyone on the spot here, but maybe Islam can shed a light on that. So from the applications perspective, let's say I'm a fresh graduate. I don't know anything about the semiconductors. I want to get my hands dirty in the design phase. Is there any open applications that can be explored, or is there any platforms that been introduced by companies, definitely Intel or any company else, that can help me as a developer or a designer to explore this phase, or can play ahead and create my design and transform this by time into an opportunity or a business or entrepreneurship, small company?
Let me leave the answer of that question to Dr. Ahmed. I think it's better for me. But before going to the answer of this question, there's something very important to be highlighted here, which is if we look 20, 30 years back, the concept of open source, open community type of projects was not like today. And the idea of the open range just mentioned here is talking about I need to open the RAN interface and doing the 5G based on open source type of application. Yeah, this is one of the extreme examples, one of the most difficult example to achieve. However, the concept itself is still very valid. There is a lot of open source projects available today. There is a lot of platforms that as many companies like Intel and others are doing and keeping for developers to use in order to build solution on top of it. In my opinion, this is an amazing start for anybody. Don't try to create things from scratch. It will take a lot of time from you, and time is more expensive than money, and you cannot buy time. So whatever there is a successful platform available today to develop on top of it, use it. There is open platforms available for controllers, microcontrollers. There is open platforms available for network definition, and in between there is a huge range. So whatever your area of interest, definitely you will find an open source project that tackle this interest. Try to explore it and work on top of it. And we have a lot of examples from already existing very successful companies in the region and outside the region who started by utilizing an open source project, then optimizing the open source project, then branching out of the open source project and building something intellectual property for them that can be backward compatible with the open source project, but it's unique for them, achieving a certain unique performance or a certain unique value of the TCO or whatever. So don't try to innovate the wheel. There is a lot of wheels in the place, and there is so many things that is easy to find. Please search for it and use it. Back to the question of the open source for semiconductors.
Yeah, I will go to Dr. Ahmed because really I want to give a space for Dr. Ahmed because his experience, and it's amazing experience. And I know after the panel will be bombarded with questions on what are these open source resources. So I will leave the floor to you to handle this after the panel. So back to you, Dr. Ahmed. These examples of platforms, these business opportunities, and the outcome of this panel, if we got some opportunities and shed the light of these opportunities from your experience, from your research, from the ICs that you have created in your past and future projects, please shed some light on that and let us know.
Yeah, so back to the question, let's assume that there is a student or someone that is an enthusiast and wants to work at semiconductors. I worked for a few years in a research lab called the IMEC. IMEC is the largest nanoelectronics lab in Europe. It's like MIT of nanoelectronics. Back in the days, we had 2,000 scientists. There is no two people that were doing the same thing. So in principle, every one of the 2,000 people was doing something totally different. Which means that if you are preparing yourself to be one of the 2,000, it means there is a specific route that you have to follow. Intel might have grown or have shrunk up to an 80,000 employee. I think now 120 or something. Mostly working in groups. The chain of semiconductors is so huge that I think The question is first, where do you find yourself comfortable? And you have the two edges of the equation. One edge, it's pure software. So it's like you're writing software for processors. And the other edge is really nanoelectronics, physics level, lithography, and so on. And these are two different skill sets. The way we did it back in the days, which was very simple, is that you find a job profile and try to fit yourself to that job profile. So figure out what they need, and then you have a list of already of things that you need to work. So if you are more into software or firmware coding, as they call it, then most probably you are heading towards C, shell, a bit of shell scripting, microcontrollers, top level, and so on. If you are in midway at design, now you need to know more about protocols, USB, CAN, serial, and I can get into deep details. If you want to actually design them, then you have to get into a bit of lower level of abstraction. If you are in the EDA software, which is synopsis and cadence, and I can get technical along the way. But the mere very simple message is you can easily fit yourself on a job description. Second, for software tools, almost for every single one of them, there is a bit of open source software. Like for hardware design, there is now a company called eFabless. It's an open source platform to connect a bit of periphery, then actually have a tape out with Google. And Intel might be already part of that program. For the other side, there are many platforms to simulate. So you don't really need money to start. That's one part of the question. The second part of the question which is the business models to work on. First, you have to look in the environment that you live at. Most of the guys that get well educated in the West, I'd say at US and America for PhDs, masters, and so on, they typically start companies over there. For our region, if that's the question, for this region, mostly those guys who traveled and came back to the region, or those who have got very good education locally, like the ones that worked for Intel, their initial target is to work as a services company. So they would start by delivering a software, or testing service to companies that are global. In Egypt, we have guys that are working for many of the top names, most of the top 10, including Intel and other companies, Mentor. They have already designed teams locally. Sometimes they have Analog Devices even has a research team, and it's a main research team in Egypt. But all of this layer is services business, meaning there is someone that takes the lead, maybe like Dr. Hisham. He already as well had this kind of work, have a good connection at one of the big corporates, start developing something for them, make a small margin on the top of it. Those who progressed beyond the services, and there are plenty of companies at automotive and semiconductors in general, would start to develop products. Eventually, these products will never be sold in the MENA region. That's the ugly truth. They develop their products, but then they need to migrate either to Germany or the States to actually make a sale. So the business models that works in our region is one basic services model. So you make a sale, maybe a couple of millions with a 20 or 30% margin. That's it. Or if you can manage the cash to have a team, like a company that is working in photonics, cutting edge in Egypt. I think they are financing over 30 or 50 engineers. They're working with top 2 or 3 photonics players globally, and no one could ever think that photonics is being developed in Egypt. Then they can develop, spin off a product, and then eventually the product have to travel. Now, if we want to take a success story, if it can be called a success story, the company of Dr. Hisham Haddaran is not here on the panel. So he started with services with some of the co-founders, some of the prominent key figures or founders of semiconductors industry in Egypt. Beyond the services, they developed their first product, a product company. They made a spin-off of 2 or 3 product companies, and one of their companies, Burl, I think, just raised $4 million, a DeepTech company for chiplets in Egypt. So I think that journey is the journey everyone from the semiconductor industry in our region has to travel. Those who have deeper insights, and now we hope that there could be cash, should start directly from being employees, I hope directly to products. But we are not there yet. There are only maybe 3 or 5 product companies of semiconductors in total in the whole region, including UAE and KSA, Saudi.
I think this is a really insightful information, and especially we are representing the IEEE here on the IEEE Entrepreneurship, which having the main goals of bridging the gap between academia, industry, and currently the IEEE Entrepreneurship bridging the gap and availing opportunities for people to start their own businesses and to start their entrepreneurship journey. And I think this is one of the opportunities that we need to take. and we need to consider. I'll get back to this again for more examples or more use cases, Dr. Ahmed, if you want to shed some light on that. But I want to go back to Ahmed Darwish and ask, Ahmed, currently we're talking about the 5G and this revolutionary 5G that coming to the market here in UAE, the 5G is rolled out. We are having 5G on our devices, thanks to whatever chipsets on the back end that help this technology in our devices and in the stations-based technologies to have this technology here. From your perspective, what semiconductors added to this technology? And even we are talking about the 6G, if you can shed some lights about what's happening, what's going on, and if this technology can be consumed, or if semiconductors can allow us having a 6G or different IoT technologies, if you want to shed some lights on.
Thank you, Khalid. Actually, this is a great question, and the way to focus the applications of semiconductors. And one of the key enablers of the 5G is the IoT and the ultra-reliable latency. Just on this stage, the previous panel discussion, I heard someone discussing autonomous helicopters. You can imagine the use case of such a thing and how critical the latency will be. And the type of connectivity and the 5G maturity, how to handle such an interesting use case. So for sure, IoT is a major opportunity for the semiconductor companies. And the way I believe it's at extent that the semiconductors are threatening the IoT's future or even limiting its IoT acceleration and development and growth. Like Dr. Ahmed mentioned here, the geopolitics and during the pandemic we witnessed this tension, and the manufacturing of the ICs, the supply was much less than the demand. And nowadays the IoT solution in an interconnected world are everywhere, where we can turn any product to a smart device, whatever the business vertical we're addressing, being transportive or automotive, healthcare, smart cities, energy, utilities, public safety and governmental sectors, smart agriculture. The use cases are a lot, and this keep pushing the industry of semiconductor more and more and requesting high demand. And whenever there's a challenge, there is an opportunity. So maybe it's a good opportunity for our region to start focusing on the manufacturing side. And semiconductors is a crucial part of the game because it's the main building block of any electrical component. So if you're discussing IoT, for example, in order to apply the IoT functionality, in order to have the proper technology of semiconductors to start executing the commands and processing the data and interacting with the physical world. And this is one of my favorite definitions when it comes to IoT. So IoT is the idea is to make any object feel and interact with the external world. For instance, this chair, if you think about it, you can just add like a Qualcomm chip, a QC4020, and start adding some sensors. It can tell my age, my gender type, my weight, keeping it to himself, of course. It can do a lot of processing, and this is just for the functionality point of view. And this is a very small example, but the idea is there for whatever business vertical is always similar. And after that comes, you collected and measured the data, it comes the connectivity. And whatever the medium we're using, being it Bluetooth or Wi-Fi or LPWAN, and what cellular technologies, narrowband IoT, 5G, I'm trying to build my way to the IoT stack. And the challenge is to be able to do all that and keeping into consideration the power consumption and power efficiency and still having this compact size, because this is the main concept of IoT. You need to deploy your IoT device or sensor and forget about it for years and decades without need to having a necessary visit to replace the battery. And with the current technology, we're hitting the Moore's law limits and the heat dissipation challenges. Keeping all the solution in a compact way and ensuring its small size, it's really challenging. And comes after that, I believe, the data processing. So you have your sensor, you collected the data, you have your connectivity on top of that, you have done it in a power efficient manner, you have to do some data processing. And the data processing here maybe it would be done locally with concept like mobile edge computing, or maybe the Intel processor, the Atom E3900, where it's relying on real-time data and can do some real-time processing. And it's always a good choice when it comes to the edge IoT. So after that, maybe you start moving, not sending all the data of the IoT, because the IoT can produce a vast amount of data, which you might block your network, so you have to do some processing pre-locally with the concept of edge computation. So, yeah, I hope this covered the questions.
Oh, that was really insightful, Ahmed, and thanks a lot for that. Moving again, and I want to focus somehow with the telco and the 6G. Islam, if you think that there is some, again, combining the research and the industry together, if there is something you are looking at or you are experienced with as a use case or something coming with the 6G researches, if there is something coming in the future, what the future is looking like from the semiconductor perspective when it comes to the sixth generation and the telco technology?
Just if you allow me to just comment on the IoT part,
Yes,
and
please,
I will move it to the 6G after. So in Intel, we have a very interesting perspective about the IoT. If you look to your body, you will find that the best sensor you have is your eyes. So if we find a way to make the cameras capable to understand what today our eyes are bringing to us, this will be a very interesting perspective. That's why we in Intel, we pledge the AI and IoT together in one concept. And we have our platform, which is called OpenVino, which is a kind of development platform. You can use it in order to develop a lot of products that make use of the AI and converting any camera into a smart camera that acts similar to your eye. And considering that the sensor is going to be a camera device, and considering that normally the camera feed is something that is heavy to the network, and as much as you increase the quality of the video feed, as much as you have to provide extra communication capabilities, the need or the use of the network from a 4G or 5G or even fixed type of technologies are going to be in place, and there is a reason why we need to develop more and more in the connectivity aspect. Then we need to think about what the connectivity today is bringing to us. If we look to the city type of connectivity, with very simple question, while you are sitting at your home, Khalid, which connectivity you are using? Is it 5G or the Wi-Fi?
Wi-Fi, definitely.
So definitely the fixed connectivity, which is based on fiber optics, is something in place today, and it is somehow exists in our life and can solve so many problems to us. So the problem of being connected within the city is not a problem, is not a big problem anymore, because with the fixed connectivity, you can able to do everything within a certain area. When we start to make a move, we think about mobile communication. We think about 2G to have a call, 3G to just have an update on web, 4G to start seeing video while we are moving, 5G to start seeing much more on 5G. Then if we think about 6G, what 6G can provide to us? 6G is going to provide a kind of coverage everywhere. We'll start to think about the space aspect. How can we use satellite to mix it with the communication on ground to provide the connectivity for us? So when you look to the 6G, don't think about an extra thing that was not before, but is a new place that was not connected before. Today, the communication over satellite already exists, but it's very expensive. It's very limited in speed. When 6G is coming, the line between mobile and satellite will just vanish, and you will start to see the same experience in home, similar to in Move, extended to the desert or any rural area. This is one aspect. The other aspect is multiple of AI techniques I'm using in order to build a use case useful for my life, but network engineers are also using to provide a better network to the connectivity. So with the Open RAN, we started to see something called Radio Intelligent Controller. We started to see an open interface that allow developers to program the network and even allow operators to open the interfaces of the network to small companies and other developers to use it in order to provide use cases for the network and on the network. So what we are going to see in the future is more merge between AI, space, speed, and other use cases, which is like we merged the concept of IoT with the video.
I think when we are leaving Earth in our journey to the moon, I'll be paying some roaming charges.
To the moon, Earth,
Telecom operators will be charging me in the outer space. So some last remarks before we finish, and I think that we need also to take some questions from the audience. But Ahmed, I know I want you to put your hat of the angel investor or the investment hat, and I ask you a question, a very simple one. You are an investor, a semiconductors investor, if you can say. What are the companies that you will love personally to invest in? What do you want to see when a company coming to you? Definitely you will invest in something that is generating revenue, for sure. But I'm talking about this technical field. What personally you love to see in this region?
So I'll answer with the focus on semiconductors and on deep tech in general. So first, deep tech is hard tech. This can inherently means that others are shallow or light or no tech. So deep tech is really hard tech, and it is hard because you have to get the founders of deep tech as a start are not the typical breed of founders. Founders as they appear on TV are hippies, are cool people, are guys, are t-shirts in black and so on. Deep tech founders are totally different. They are usually PhDs with 10, 20 years of experience, very solid technical experience, working at the cutting edge of whatever shit that they are doing. So they know what they are doing. That's one part of it. Second, they do not typically do platform stuff or buy now, pay later stuff. They build things that takes years in order of 3, 5, maybe 10 years. One of my successful angel investments have been in an airplane company, and I was investing like 7 or 8 years back then, and they are still developing or building their product to the moment. And I assume that they will maybe make their IPO maybe in 7 years more. So a deep tech investor looking at the deep tech company first understands that those founders are different type. The type of founders that we love to see are typically guys with very deep knowledge on what they are doing. So it's not an idea it's not an inspiration. It's a result of very hard work for few years. That's one. In the domain of semiconductors, we have witnessed some founders that made 1 or 2 exits. Typically, exits in deep tech are not usually as sexy as others. These are companies that are usually sold in the orders of tens of millions, 60 million, and there is a reason for that. Usually, most of the domains are dominated by conglomerates. Like if you're developing something in the EDA of semiconductors, there is only 2 EDA companies. It's either Synopsys or Cadence. There are other small players, but these are the big names. If you're developing something meaningful, this means that one of these 2 guys have to acquire that company. So, and as such, when you look at a company on day 0, 1, you're looking for an expertise of that guy that is cutting edge in whatever that he's doing. 2, he knows to whom he's solving a problem, which one of the 2 conglomerates or 3 conglomerates that are dominating his field. 3, it's not only about the person, it's always about the team. Semiconductors and the deep tech in general is cumulative knowledge. It's not something that you get up and let's commune 3 founders and build it. Usually it's a build-up of many years. I've met companies that used to work initially in services. They build up teams, coherent teams that can build up something, usually in the order of 10 to 20 engineers from all disciplines. Sometimes you need digital, analog, high frequency, low frequency, firmware coding, modeling. It's not one domain. Then these guys might have been working already for 3-5 years, and now they are starting a product. So these are the things that we're looking not in founders even, but in companies. I had the opportunity to profile the market of Egypt and MENA at DeepTech, and I would maybe give a very quick summary of what I found at different domains. Countries like UAE and KSA have a great edge in biotechnology. For the simple reason is that the regulation here is not that developed, or it is way relaxed towards developers, that the cutting edge developers at biotech are already living in UAE and in Saudi Arabia, where they can experience or test all their crazy ideas in a legal fashion. In semiconductors, Egypt beats the hell of all the Arab region. We have an enormous number of engineers. Sadly, most of them are working in the services industry, not in the product industry. Yet, few are moving now to product. For cybersecurity, I know the number. There is 50,000 engineers in cybersecurity, which is again a deep tech technology, if you're working in cryptography and so on. However, these guys generate a couple of million US dollars for the sad reason that they are all working in the services industry. Whereas it makes more sense if you have this immense human capital to switch them to products, which will mean as well more money for the whole region. So I'll stop it here, but the message is human capital exists, mostly spending time in services where they should spend it in products with a bit of investments.
That's really insightful.
If you allow me just to Doctor, do we have in the region the catalyst that able to convert us from a service to product?
Sadly not. So we have two major gaps. One gap that is being filled here. That's to take research into product. It is very difficult to convince my brother, who's have been an engineer, to start having a business. That's already one journey. So you need someone that could help them from academia to institutes to think of products in 10 years to come. And then you need some other group of people to take them from thinking in 10 years terms into 2 years terms, which is product. So there are two different gaps. We have definitely both gaps. The first one, I think this GIA is trying to fill, which is taking researchers to business, from research to consultancy services. But the other jump from services to products, it's a blue ocean. There is none, as to my knowledge. Very few funds that claim to be doing it, but none is doing it in a systematic way yet.
In my opinion, it's not only funding. Funding is the easiest part of it.
Ecosystem.
Well, that's an interesting discussion, and I think that we need to open for the questions. But as we ran out of time, so I'll take just one question because we'll have 1 minute. So please, go on.
2 questions.
Okay, I know my question gonna be really harsh, but my question gonna be really useful, because let us put down the technology. You're already specialists. Let us think about philosophy. Why we are here today? Technology is the tool for human being to living a better life. Better life means Africa people also have enough food and everything bring by our technology equally, because people, human beings were born equally. Technology is not something like our business card to show off. In this case, shall we think in another way? If we are talking about making technology go to the right path to help human being, if semiconductor kind of thing can be manufactured by China, then the prices will all go down, and everything based on that, the price will go down. And not only the rich people in the rich region by the war too, God of fortune can use it, but also all human beings can equally use that. Why we are talking about academia and then research and then manufacturing, there's a gap. Because there's an ecosphere which we did not establish. Why is not established? Capital. So maybe we can think by philosophy way to solve the technology problem. That's my idea. Thank you so much.
Thank you for this idea. I think this is not a question. So I think we'll wrap up this panel discussion with 30 seconds left. So if there's one question left, we can take one more question, but it will be 30 seconds. If it will take 50 seconds, then we can do this.
My comment is about closing this gap, and I think there is a lot of effort starting to be done, and I'm so happy to have this. I want to comment that what is done by IEEE Entrepreneurship and what is done by IEEE TEM Society is doing a great achievement to close this gap. And by the way, when we are speaking about the mission of the IEEE, it is about humanity and about the benefit of humanity. This is why we're leading this as a IEEE Entrepreneurship and IEEE TEM Society. Thank you.
Thanks a lot, Shams. So leaving this panel with lots of energy, and I hope that we continue this conversation afterwards. I hope that we fulfill the quest of IEEE Entrepreneurship Region 8 and IEEE TEM Society and all the other IEEE and GITEX event as well. So my thanks go to all of you for bearing with us this 30 minutes. Dr. Ahmed Darwish, thanks so much. Salam Andil, thanks so much. And Dr. Ahmed Abdel Hamid, thanks so much. And myself, Khalid Mukhtar. Thank you.